Hello everyone, I am Abhishek Datta and you all are watching my YouTube channel Mathematics Made Easy. Today in this video, I am going to discuss about the consistency of a system of linear equations. That is our topic of discussion today. So, what do we mean by a system of linear equations? Let us explain. First, what we mean by a system of linear equations. So whenever we speak about a linear equation, that means an equation having degree 1, that is the variable or variables involved in that equation should have the highest degree 1, that is a linear equation. And if we have a collection of such equations, that is 2 or more than 2 linear equations, then accumulation of such linear equations form a system, so that we call a system of linear equations. So by a system of linear equation we mean 2 or more linear equations which we have to solve for the variables involved. Now for the simplicity of the discussion, let us start with a system of linear equation involving two variables only, that is x and y. Then we shall continue our discussion to the next level, that is the system of linear equations having more than two variables, 3, 4, 5, etc. But the basic discussion should be on a system of linear equation having two variables x and y. So let us now take a system, such a system of linear equation. So since we are having two variables here, x and y, so the system must contain two equations. The number of variables and the number of equations should be same. So let us consider one equation as a1x plus b1y is equal to c1, and the second equation to be a2x plus b2y is equal to c2. So these two together form a linear system. These two equations together form a linear system where a1, b1, c1, a2, b2, c2 are the constants and x and y are the variables of the system. Now to find a solution of such a system means to find the values of x and y which will satisfy both the two equations simultaneously. So such values of x and y are said to be a solution to such a linear system. Now what we mean by consistency of such a system? By consistency of such a linear system we mean that there exists at least one solution to this system, which means we can find at least one value of the variable x and at least one value of the variable y which will satisfy both the two equations simultaneously. Now in this discussion we are not going into the details of how to solve the system. Rather we shall explain the method of determining whether this system can be solved or not, that is whether the system is consistent or inconsistent. If the system cannot be solved, then the system is said to be inconsistent, otherwise it is said to be a consistent system. Now the consistency rule suggests that if the ratios of the coefficients of x and that of the coefficients of y in this system are unequal, that is if we have a1 upon a2, that is the ratios of the coefficients of x not equal to b1 upon b2, that is the ratios of the coefficients of y, then such a system shall always be consistent. That means we can always find a solution, that is a pair of values of x and y which will satisfy both the two equations simultaneously. So this is the condition for which this system shall always be consistent and it will also possess a unique solution. So under this condition the system is consistent having a unique solution. So by a unique solution we mean that we can find exactly one value of x and exactly one value of y which will satisfy both the two equations simultaneously. And geometrically, we know that a linear equation represents a straight line in two dimensions, that is, in terms of x and y, every linear equation represents a straight line. So this equation and the second one, they represent two different straight lines. So geometrically, if a1 by a2 is not equal to b1 by b2, we shall have two distinct straight lines intersecting at some point, say P, whose coordinates, if say a and b, shall give us the solution to this system. Because the point of intersection being common to both the two loci, these are the locus of straight lines. So P being the common point of intersection, coordinates being a and b, that is x value of P being a and y value of P being b, it will satisfy both the two equations. So whenever we have a system of linear equation in two variables which is consistent, algebraically that will imply that the ratios of the coefficients of x and ratios of the coefficients of y are unequal. Geometrically, we shall have two distinct straight lines intersecting at some point P with coordinates AB. These values a and b, that is abscissa and the ordinate of the point P, shall represent the solution to this system. Next is when the coefficients become equal. What if a1 by a2 becomes equal to b1 by b2? So if the coefficients now becomes equal, that is a1 by a2 becomes equal to b1 by b2, but not equal to the ratio of the constants C1 and C2. If we have such a condition that the ratios of the coefficients of x is equal to ratio of the coefficient of y, but they are not equal to the ratios of the constant terms C1 and C2. Under such a case, this system will be inconsistent. That means we cannot find any solution to such a system. So under this condition, the system will be inconsistent. That means there will exist no values of x or no values of y that will satisfy the two equations simultaneously. And geometrically, under such condition, we shall have two parallel straight lines. Basically, these two will represent two parallel straight lines. And as we all know, that two parallel lines never meet at a point. So there will be no point common to both the two locus, and hence no common value of x and y would satisfy both the two equations. So for such a condition, that is when the coefficients of x ratio is equal to the ratio of the coefficients of y, but they are not equal to the ratio of the constant terms, then this system will be inconsistent. That means there would be no solution, and geometrically they will represent two parallel straight lines which will have no points in common. On the other hand, if we have the equality in the third case also, that is if all the three ratios becomes equal, a1 by a2 is equal to b1 by b2 is again equal to c1 by c2, that is the third condition. Under such a case, the system shall again be consistent. We shall again have a consistent system if all the three ratios are equal. And not only the system will be consistent, but in this case, this system shall have an infinite number of solutions. So this is the condition under which the system will be consistent and having infinite number of solutions. So geometrically, these two lines will then coincide. If the ratios becomes all equal, that is also equal to the ratio of the constant term, then geometrically these two lines will coincide with each other. So we shall be having one and only one line. Actually, basically they will coincide. So each and every point would be a common point to both the two loci. So hence every point on the line shall represent a solution, because between two coincident lines we have infinitely many points in common. So under such a case, this system shall have an infinitely many solution. So this is how to determine whether a system of linear equations in two variables shall possess a solution or not. That is, if the system would be consistent or not, and if consistent, whether the system shall have a unique solution or an infinite number of solutions, or it may have no solution also. But one important point that should be noted, that for such a system, that is a linear system involving two variables x and y, we can have only three possible cases. That either this system shall have a unique solution, that is exactly one value of x and exactly one value of y, satisfying both the two equations, or we may have infinite number of solutions, or we may have no solutions at all. But there cannot be two solutions or three solutions likewise. Either it will have no solution or exactly one solution, and if more than one solutions exist, they should be infinite in number. There cannot be two or three or four solutions for any linear system. So every linear system must possess either no solution, then we call that inconsistent, or a unique solution with consistency, or an infinite solution. So that is how we determine the consistency of a system. And we have also discussed the geometrical implications. For no solution, we shall have two parallel straight lines. For infinitely many solutions, we shall have two coincident lines. And for a unique solution, they will represent two intersecting lines. So this is all about the consistency of a system of linear equation in two variables. We shall discuss about the consistency of a linear system having three or more than three variables in our next videos. I hope this video is useful to you. If you have any problem or any questions or any doubts, you can ask me in the comment section. Thank you all, and please like my video. If you are new to my channel, you can subscribe to my channel also. That will help my channel to grow. Thank you all.